Okay. So what we're going to start with is set theory. Okay. So the first thing involving set theory is we have to go through some definitions. A union B that would be all X within U such that X is in A or X is in B. All right. Now, when we draw a union, so make this kind of big. We call this set A. Well, that's set B. So the union of these sets is going to consist of, let's draw it like this. Okay, so what's meant by union is it can be either in A or in B. Okay, so we have the concept of union. There's really four basic ones. And then we have an intersection. Okay, so A intersecting B. So that would be X within U such that X is in A and X is in B. All right, now if we draw this as a picture, that would just be the intersection. And I'm actually going to do the complement. I'm going to go a little bit different from your book, because I'm going to describe the complement before I describe the difference. So that's the intersection. Now, what if we said the complement? This is actually, you'll see this written in several different ways. If you go into a statistics class, the complement will not be described as in a to the C, but in this class it will be written like this: A sub C such that X is in U and X does not equal A, and actually that dash symbol can go either direction. So the complement of A is everything such that X is not in A. So if this is A, this is B. If we're saying the complement, this means all X within U, and we could just describe this general domain as U. So it fills up all of that. Okay. And in other classes, that C that appears right here will appear as a dash. Okay. And then there's the difference. B minus A, which would equal all X in U, such that X is in B, oh, well, I guess I didn't write down, this is the difference. Okay, so B minus A. So we have to consider, all right, so how would I draw X is in B and X is not in A? Okay, so X has to exist within B. But not within A, so it doesn't exist within the intersection of this. but you're not always going to see this represented as B minus A, or other ways it says B slash A, okay? What is another way to represent the difference, okay? We can also represent the difference as an intersection of, well, let's look at this one right here. So A sub C, now when we say the complement of C is would contain the difference, okay? So if I said, okay, well, the complement of A sub C does contain this difference right here. So it would actually exist as a subset of A sub C, okay? So what would be another way? All right, so you're looking at this shaded region right here contains the difference. All right. Now, if we're talking about a union or an intersection, what is, put it this way. Okay, so we have these two images right here. So what is another way to recognize what B minus A would actually be? Well, B minus A would actually be B's intersection with A sub C, and we'll write that B minus A. Okay. And now, think about what this statement is actually saying. It's saying X is in B and X is not in A, okay? This intersection symbol right here would mean, well, yes, B is in, X is in B and X is not in A. Okay. Well, let's take this a little step further. Let's say we wanted to investigate A union B sub C. Now, what is this statement equivalent to? X is in U such that X is in A or so A union the complement of B. Let's try to draw the diagram for this one. So A union the complement of B. Well, let's consider the options that we have on this. All right, so X can exist within A. All right, well, that's our first one. So, if X is in A, can exist within A, well then it'll fill up A. So let's just go ahead and we'll completely fill up A, because X can exist within A. Okay? But A union with the complement of B, it says, well, yeah, X can exist in A, or X does not exist in B. So, if X can exist within A, or X cannot exist within B, what ends up happening? The rest of the space gets filled up. Okay, now a lot of people, when you see this diagram, they would look at the intersection of A and B and say, oh, why are you filling this in right here? Because you have this statement right here, X is not in B. This is an or statement, not an and statement. So X can exist within A, and there is this intersection with A and B, but this is an or statement, not an and statement. Okay? So X can be within A, or X cannot be in B, or X is existing within the complement of B. Okay? So that's why we include the intersection of this part right here. Okay, so that's A union, the complement of B. What if I said wait, did I already do this one? Yeah, I did the A complement and intersection B already. All right. We'll go to the next one. So we're going to have a look at this one. The complement of A union with the complement of B, is this equal to A intersection B's complement? Okay. Now, sometimes this is referred to as De Morgan's Law, but actually they name multiple theorems De Morgan's Law, so it loses some meaning. Let's try to figure out what is meant by this statement. Okay, so A complement union with B complement, how would we write this? Well, X is within the domain such that X is not in A, or X is not in B. Okay. So if we start with this picture, we can say X is not in A or X is not in B. Now what is the equivalent of this statement? okay? So this statement can be interpreted in two different ways. You can say X is not in A, or X is not in B, or X is not in A and B. Right? So if we drew a diagram of this, honestly, the second one seems to make a little bit more sense to me. So if I was going to say X is not in A and B, you can basically say X is not in the intersection of A and B, okay? If you look at the first one, you can say X is not in A, or X is not in B. Okay, that takes a little bit more of a logical process to go through, rather than saying X is not within the intersection of A and B. So, if I say the second one, X is not in the intersection. Well, actually, let's do the first one first. All right, so let's say, okay, X is not an A. Okay? So X is not in A. And this would be the set that X is not in B. Okay? So everything surrounding the circle of A, that's saying X is not in A. Everything surrounding the circle of B, X is not in B. So if we say X is not in A or X is not in B, what would that be? That would be a union of these two. And so the union of these two, X is not in A or X is not in B, A right there, with B right there. Okay, let's highlight this intersection right here. Okay. So that means that X is not in A and B. Okay, and we talked about this earlier in the semester about the negation of a statement. And so if I was going to say the negation of a statement, okay, so I was going to say A and B, okay? I was going to say X is not in A and B. Well, that would be X is not in A or X is not in B. Difference between and or statements. I know it's just a single, it's just two words, but they actually carry quite a bit of meaning. Okay, so how would we, I'm kind of loosely writing this, and so, but what would be the symbolic way that we would actually write this? X is not in A or X is not in B is equal to X is not in A and B. And I already wrote this once, but I'm going to write it again to try to reinforce this. The complement of A unioned with the complement of B is equal to A intersection B's complement. And like I was saying before, if you're in a statistics class, these C's will be replaced with dashes. Okay? And sometimes little bars over them. The notation is not always consistent. So that's why when I draw these pictures, I'm trying to get the idea across. You want to visualize the picture itself rather than just particularly paying attention to the formulas. It's more of a mental concept. Okay. Did that one? Okay, so what if we did this in a slightly different way? Okay. Let's say A sub C intersection the complement of B is going to equal a union B complement. Okay. Now, if we're going to write this in our standard notation, well, A's complement intersecting with B's complement, what would that mean? That would mean X and U such that X is not in A and X is not in B. So the complement of A and the complement of B. Okay. Now, what would the other statement mean? We have the complement of A and the complement of B, but this is equal to that other statement, A union B's complement, which would mean X within U, such that X is not in A or B. Now, when it comes to these two statements, both of them seem to make sense to me. But let's look at what this would actually look like. So X is not in A or B. Well, within that shaded region, X is not in A, X is not in B, and X is not in A or B. This is going to be kind of a long video, but oh. All right. Now we have something that is known as the distributive law. What if we took it a step further and we said, okay, we can, normally people talk about Venn diagrams, you got an A and a B, and an intersection and a union. What if you added in a third one? So there are two, all right, so we went over De Morgan's law. Now, if we talk about the distributive law, okay, so there are two of these. A union B intersection C is equal to A union B intersect with A union C, and A intersect B union C is equal to A intersect B union A intersect C. All right, and now let's see how we can actually draw this graphically. Well, let's just start with the first one. I'm going to run out of paper if I do that. Let's start with that first one. No, we'll start with the second. So let's say A intersect B union C. A intersect B union C would mean X is within U such that X is within A and X is in B Okay, so A intersect B union C. So X has to exist within, X is going to exist within A and B or C. Okay, so now we're going to have to draw 3 circles. Okay, so A, B, and C. Okay, so now this is saying X is in A and X is in B or C. So if I start out with just that first statement. Okay. So X has to X is an A, and it has to be within B or C. So what is meant by the second statement? X can be in B or C. Okay. So if I draw B or C, big C. So X can exist within B or C. Okay, great. Well, that means that what would that fill in? All of C and all of B. Okay, so we can fill in all of B and all of C, but this is an AND statement. And since this is an AND statement, so X is in A and X is in B or C, what does it really mean when you say AND? It means intersection. So the intersection of these two shaded regions will be X is in A and X is in B or C. So if we were going to draw this thing, A intersect of B union C, what would this be? Be the intersection of the previous two graphs